All right. Hey guys, how you doing? It's Melendez again, doing a little video for you, pre-rec guys. Haven't done one in a while, so doing another one today. Real quick before we get started though, I'll try to keep this short so it uploads a little bit faster. Don't forget you guys to log into a SurveyMonkey daily, preferably, if not at least minimum 3 times a week. Do 2 questions, 3 questions, just so you guys are staying active on the SurveyMonkey questions, right? Remember, any concerns or complaints or questions that you guys have, feel free to email me, write it on the Google Classroom, or text me or call me, like some of you guys have been doing, all right? So we're talking about electricity in the HVAC world. There's always going to be a certain amount of tools that we're going to need. Obviously, the more you get into the trade and the further you progress, the more tools that are going to be accessible to you. But for the bottom where you guys are going to be, that's not a bad thing, but that's just the basic tools that you guys are going to need. There's always going to be a couple that stick out. And obviously, it's going to be basic hand tools and all that stuff. But when we're talking about electricity, there's really 3 to 4 that you guys are going to kind of stick with, and these guys are going to be the ones that you carry on into your entire career. All right, the first one, which isn't the main one we'll get to here in a little bit, it's going to be this little guy right here. You guys can see that. All right, this guy here is a crimping tool, right? So if we open it up, you guys can see that up here you guys have the cutting head. All right, that's where you guys are going to be cutting wires and stuff like that. All right, now these guys here are only designed to cut electrical wire, not conduit or pieces of steel or anything like that, just copper wire. Okay, and then at the bottom, turn these guys around. You guys can't really make those guys out. Maybe you can, but up here you actually have the crimping tools, right? So when it comes to these 2 guys here, the one that has that little nipple right there, right, that's going to be for non-insulated fittings. And then a little bit lower at the bottom is going to be for insulated fittings. And here I'll show you guys the difference between those 2 guys. So these guys here are going to be your one of your main guys that you guys will use in the trade, right? The other one, if you see me looking this one, I'm by myself and there's weird noises going on. But anyways, the other one's going to be these guys here, and these guys here are a combination of strippers, right, and crimping tool, right? These guys here I personally don't really care for, and I should have brought my set, but we're doing what's in the shop. The reason I don't like these guys, because sometimes, and this just may beat me, but sometimes these crimping part here doesn't really crimp the fitting too well, and you can't really put a whole lot of torque or downforce on these guys. So sometimes you get a bad cramp or something like that. That's why I always go with these guys here. Now my set doesn't have the crimping; it just has the stripping side. And obviously, to crimp wire, I would use these guys here and crimp the wire with this guy. All right, but this guy here, it basically takes that guy's job and incorporates into this tool. It does crimping and stripping. Now these guys here, hopefully you guys can see that here. Now on this side here, you see that it has numbers, right? 22, 20, 18, 16, 14. And then on this side over here has the same numbers, right? Now the difference in these 2 guys here is that one side is going to be for solid wire. The other side is going to be for stranded wire. In HVAC, we tend to use stranded wire a lot. We hardly run into a solid wire, and I don't have any solid wire here, but let me find a little piece that's cut up. Right, now this guy here, it's all cramped. Let me get you guys a new piece. All right, so these guys here, if I spread them apart, you can see that these guys are, just like the name says, it's a stranded wire. right? Solid wire would just be a solid piece of copper that runs through here. I wouldn't have any of these little strands sticking out. Now there's pros and cons to everything. These guys here, they're a little bit more flexible. You can run them around corners, make tight bends with these guys, and they're pretty good. With solid, they tend to be a little bit more rigid. You can't really make them go through. If you do get it to go through a panel and you pull on it, sometimes you do tend to cut this and make splices, and then you create a shirt. With these guys, are a little more flexible. Not only that, these guys are a lot easier. I don't have any conduit here, but they're a lot easier to run through conduit. I thought I did. So these guys will actually bend inside the tube and all that. Let me go get some conduit for some of you guys that might be wondering what conduit is. All right, so this guy right here would be a conduit, right? So you will have this plastic tube here, right? Also known as EMT, but EMT is for electromagnetic tubing. You guys get what I'm saying, right? Tubing for electrical wiring. Getting tongue-tied a little bit. So you would take this wire here, shove it through here, right? And then this guy would just go through here and come out the other end. And obviously we have some fittings that will go on both ends, and you can mate them up to a box, electrical box or something like that, or a disconnect. And it's basically to protect the wire, keep everything a little bit cleaner. And that's what this guy would be doing inside of that. And if you run solid wire, obviously you won't be able to make the bands, and it just looks a little bit nastier. So this guy here is a flexible one, right? So you can bend this guy here, right? And the EMT would be electrical metal tube, right? So just like the name says, metal tube would be a solid piece of tubing, aluminum tubing, that you would run up the walls. And obviously when you guys get to the shop, you guys see that we do have a lot of EMT up here running around, and that houses all the wiring, right? But if you had a long run, you would use EMT, get that guy to a long run, and then run down the wall, obviously. But say you had, for whatever reason, it was offset a little bit, and you didn't feel like bending the tubing, you can just get one of these little guys here that bends and hook this guy up there, right? That's your conduit there. Now, moving on, the main tool that you guys are going to use when you guys are out in the field, and mine was going to look a little bit different than you guys. This is a little bit older model, but this little guy right here, right? So it's going to be your meter, electrical meter, all right? So this guy here does voltage, AC and DC. It does ohms, resistance, continuity, and we'll talk about continuity here in a little bit. Microfarads, which is a big thing in our trade, and also does temperature, right? So this guy can do it. And then at the top, you guys see it has that little clamp right there, right? So before you guys get a little bit ahead of me, this guy here is not to clip onto your belt loop and have it there. This guy is actually to check amps or current that's going through a wire, right? So we'll talk a little bit, this guy a little bit more here. So when you guys are checking amp draw, any motor that we use in our trade is going to pull a certain amount of current, right? And on the data plate, it's going to have what current is supposed to be going through this motor, or what the amp draw we call it, the amps. All right, so we want to know what's it doing, how much is it pulling, and that's good to know, because if the data plate on the motor tells you, hey, this motor is designed to operate on 3.2 amps, right, and you go in and you check it, and it's pulling like 3.6, right? So it's above what the nameplate says, right? So that will tell us there, hey, this motor is overworking. And us as a technician, we have to figure out, why is this motor overworking? Is it an airflow issue? Is the motor going bad? Is the bearings out on it? You know, something's causing this motor to work a little bit more than what it should. And this is a good tool for us to help diagnose that, right? or it can be the opposite end, right? It could be calling for 3.2 amps, right? And maybe it's pulling like 1.6 amps, just throwing out fictitious number. Well, now, because we clamped this guy on and it tells us, hey, this guy is not doing the work it's supposed to be doing. Again, us as technicians have to figure out, why is this motor not doing the same amount of job that it was in the past? Something's going on with this motor, right? So we have to figure out what is causing this motor to not work properly. So the way we check amp draws, you're gonna have a bunch of wires that are sitting there. Right here, I got 3 of them. I got a green, a purple one, and a blue one. So anytime you guys are checking amp draws on a motor, you're gonna have wires that are sitting there, right? So when we check amp draws, you're gonna take your clamp, and I'll do the green one because it's a bigger one. But you're gonna take your clamp, you're gonna set it on this one here. You're gonna set it just to the volts, right? And you can see here, at the bottom is gonna tell us our voltage, and at the top, it's telling us our amps, our current. So if this was hooked up to a motor and the motor's operating, all we would do is take this clamp and just clap it around that single wire, just like so, all right? And these two guys would be off here. And this guy will tell us, hey, this is how much amp draw or current this motor is using or is pulling, right? And then you would take it off that guy and then hook it up to the purple one, right? And same thing, it'll tell us, hey, how much amp draw is doing. And then after that, you will go to the blue one and it'll tell us our current, our amps, all right? And that way we can see, what is this motor doing? Is it overperforming, underperforming, or is it right? So it's still on that voltage setting. So now, if we were to check voltage, we will use our leads here, right? So put this guy right here for now. So we will take these leads here and we will check our whatever we're checking. Say we're checking this board here, right? And we want to know if we got power to a certain component here, right? So let's just go with the thermostat, right? We know the thermostat is going to operate on 24 volts. So if we wanted to check the thermostat, we would go to our red, all right, which is right here. One lead will go to a red. The second lead will go to our common, right? The positive and negative, right? So, and that will tell us, hey, if you got 24 volts or if you don't have 24 volts. So if we're checking 120 volts, down here, I don't know if you guys can see it. Down here is our neutral power, right? And then over here is going to be our positive power. So on this particular one, we're going to have 120 volts neutral, common. Then over here, we're going to have 120 volts positive. All right, so we would just find this guy here that says L1, which should be carrying 120 volts. And this guy over here, neutral, is not going to carry any volts for us. So it's going to be 0. And then we'll hook it up here, and it'll tell us whether we have 120 volts or not. Okay. So this guy right here is going to be, the guy that protects you from voltages, from getting bit, as we call it in the trade. Don't get bit. Don't get shocked. I know some of you guys that were in that first Zoom class that I made. I told you guys, my German used to tell me, hey, if you got to put your hand into a cage full of venomous vipers, how are you going to do it without getting bit? A lot of you guys said, put on the glove and then all this and whatever. But no, the way we're going to stick our hand into this cage that's full of vipers is take the snakes out, right? We're going to take the snakes out and then we can stick our hand in there all we want. Well, how are we going to know whether all those snakes are out? Well, this guy right here is going to tell you, right, whether this unit's still live or this unit still, it has no power. So we're going to use these 2 leads. We're going to look at the screen. It's going to tell us whether there's voltage or there isn't any voltage present, right? So this guy here is going to save your guys' life a lot. Not only that, it's going to allow you guys to troubleshoot a lot more efficient, a lot better, right? So take care of this little guy. The one I got 17 years ago when I graduated from a trade school, it still works, still operates. Obviously, it's a lot dirty because it's been through hell with me. But I took care of it. I still have the original pouch. I still have the original instructions, the original leads. Everything works. Not a crack, not a scratch. Well, a couple scratches on the body, but not on the screen. I took care of my stuff. So I still have it. And that's one thing I will tell you guys, that any tool you guys purchase, once you get into the trade, take care of that stuff, man. You don't know when you're going to go out to the middle of nowhere, and this newer technology is going to take a dump on you. You can always rely to, you know, Old Faithful here. This guy, it does his work. It really does, right? And then the other setting I forgot, right, is going to be continuity on this guy, right? And you guys also have this on your guys' meter. You just, you know, mine looks a lot different. So when we're checking continuity, what it is, and I'll give you guys a basic description of what it is continuity will tell you basically if you have a connection from point A to point B. So if we go back to my little wire, right, and for whatever reason, I can't see this middle section because it's going around a band or whatever. I can't see if this wire is cut, you know, it has a short or whatever. I can't see it. So I want to know whether there's, you know, a solid line of connection between the top to the bottom, you know. So what I'll do is I'll take this guy, set it to continuity, and as you guys can see these leads here, and I'll stay quiet and see what happens when I touch the leads together. You guys heard the beep, right? So what it's saying is that the voltage or the signal from the meter is coming through the red wire, right? And then it's coming back on the black wire, and it's telling that meter, hey, I just sent out voltage or a signal and I got it back. So there's a solid connection right there, right? So if we were to use this little wire here, right, we'll take it from here and then hook it up to the other end. The wire is solid, right? There's a solid connection between here and here, right? So this guy tells us if for whatever reason we can't, you know, rip apart the unit and chase this one wire, if we know where it starts and we know where it ends, we can use the meter, set it to continuity, and these guys will tell us whether there is a solid connection or there isn't. The other thing we can do with this guy here, right, say for whatever reason, and this happens a lot inside of compressors, right? For whatever reason, you got these two wires. We'll just pretend for right now. All right, put these guys up. We'll pretend for right now that these two guys here are two different wires. Two different wires that shouldn't be touching. No way, no how, right? They shouldn't be touching. You got a positive here and a negative here. Let's just pretend for right now, right? You keep blowing the fuse. You can't figure out why. You're going insane because you don't know what's going on. Again, this meter is going to save your life here. Or make your life a lot easier. So you can't figure it out. You don't know what's going on. You just know that, hey, every time I turn this unit on, I blow a fuse. All right. We switch this guy to continuity again, just like I showed you guys here. You're going to put one on one end, and you're going to get the other one put in the other end. If you know for a fact that these two wires should not touch, but yet you have continuity between them, right? That tells you as a technician, and we call this a short. It tells you as a technician that these two wires are touching. And again, remember what I said, this is positive, this is negative. Just because we got continuity between these two things, there's your short. The positive is touching the negative is touching the positive. Doesn't matter. They're touching, they shouldn't be touching. And this is why you're blowing a fuse, whether it be 24 volts or 120 or 480 or whatever the voltage may be. These two guys are touching. Shouldn't be touching. That meter just saved you 10, 15, 20, half an hour, 2 days worth of diagnosing why you're blowing a fuse, right? Yeah, I just told you right there, these two wires are touching, they shouldn't touch. All right, then you can move on from this. Another way we do this is in compressors, right? Compressors have windings inside of them. All there are is just copper wire that's wrapped around inside, but they're supposed to be different or separated, not touching, just like that wire. So sometimes it will pop the main fuse for the house if the short is too great. Again, we'll take our meter. I don't have one here, but these compressors out. Look, here we go. Right. And this guy here is a capacitor, and we'll talk about this guy a little later. But you guys can see in the front, you have 3 posts, right? 3 different lines. So if I take that meter and pretend this is a compressor, and I go from here to here, and I got continuity, all right, cool. This compressor is designed to have continuity between here and here, all right? If I go between here and here, same thing. All right, this is designed to have it. We're good. if I go check all three of them and they all have continuity between each other, we're good, right? That's what the manufacturer says. We're good, okay? Now, the manufacturer tells you you should not have continuity between any of these posts to ground, right? Now, inside these refrigeration units, you're gonna have copper. Copper is a pretty good ground, right? Let's just say you go from this guy here and you go to a ground wire or a metal piece on the unit, and you go from here to that metal piece and that meter beeps. What does that just tell you? All right, that just told you that, hey, there's continuity between these two things. Again, just like I explained with that wire, there's a short, right? So meaning that this winding inside this capacitor, or inside this compressor, shorted out, and it's causing one of the windings to touch ground. That's why you're blowing a fuse, right? It can be any of them, any of these three posts. As long as one is touching ground, you're done. You got a straight short, direct short. There's no way, no how this compressor is going to operate for you, okay? And again, if you guys have any questions, or sometimes I do get tongue-tied and I say stuff and I don't catch it, and then you guys are like, wait, what the hell? Write in the comments on Google Classroom, text me, hey, you know, during this section of the video you said this, but earlier you said this, or later on you said this, and I'll come back, watch it, and I'll sit there and be like, hey, I'm a dumbass, I shouldn't have said that, right? I'm trying to hurry up and speed it through just so I can make this video a little short. That way it uploads a little bit faster for you guys, right? So we have different types of fittings, right? So here, let me go over the yellow one, right? So here we have a yellow fitting. You guys can see that here, right? We look in the front. All right, you guys can see. Where's the camera? You guys can't really make it out now. All right, but this guy here is what's called a quick connect, right? And it's yellow, and this is what you guys have to learn pretty young in the trade, is colors tell us sizes in our trade, right? Like here, this yellow one, that tells us that this quick connect is designed to be sat on a wire that is between 10 gauge and 12 gauge, right? Then we have this blue one. This guy's going to be 14 to 16 gauge, right? And the red ones, I forget, it's going to be 22 or 16 to 22 gauge, which is a very tiny wire, right? So you have different colors, right? Same thing with wire nuts. You guys can see the wire nuts, all right? So they all have different colors, but these guys here, right? We'll go with the connects, right? These quick connects here are designed to be set on those spades like that, right? So this guy would just go right in there, boom, she's done, right? Now obviously the wire go here and take off, okay? That'll be your quick connect. And then you also, that's a female quick connect, right? This guy here is a female quick connect, okay? On one side. And this guy here is a male quick connect, all right? So if for whatever reason you got these two pieces of wire, all you can do is take the male, the female, mate them together. All right, come on. And there you go. You got a solid connection here. So all you would do is just tape this up for a quick or a quick connection, or if you're gonna leave it there, obviously you would do something a little bit different than this, right? If you're gonna make those two wires together, we will go, I'm pretty sure some of you guys have seen these with this little guy here, right? These guys here are called butt connectors, right? You guys move my fat thumb out the way, right? You can see right through it. So one wire will go here, the other wire will go here, and then you would just crimp these guys on both sides in the middle, make a solid good connection, right? Or you can go with these guys, obviously the wire nuts, put those two wires in here, turn this guy, and then we're good. All right, so real quick, we're going back to stripping, right? I'm at 24 minutes. I'm gonna try to stand to 30 minutes. All right. So here we have a wire. This guy here is a 16 gauge wire, right? So what we would do when we're stripping this, we will find 16 gauge stranded on this end. All right. So I found it here. You should just do one little pinch like that. Okay. And see how that guy came out pretty quick, right? What you don't want to do is just go, it should land. That's where it goes. And then start, doing this whole playing with it. If you're doing that, you're obviously not using the tool right? And I've had a lot of students that go, I can't get this to go. I can't get this to go. Our first question is, what size gauge are you trying to use your strippers at? It doesn't matter. It does matter. All right. So you should just be able to cut here with the stripper size and then just pull that coating off. Right. And see, you have these two nice little pieces there. So, and I'll go with this guy here because it's already done. What you would do next is just take this guy here and put it right there. Right, just like so. But if you see, if we bend this guy a little bit, you have exposed wire, right? So you guys can't really see, but on the inside you have a small little stopper. It kind of tells the wire how far it can go. So you don't want to have a big length like that. You want to have a little bit smaller length. Should be about there now. So now when we stick this guy in, the wire goes all the way through. Where we cut the wire is covered by the coating here, right? So when we bend it, no, slipped out. But when we bend it, the wire is not exposed, it's actually sitting inside the insulator, right? So we would just stick this guy in so like so. And there you can kind of see the wire sticking out a little bit here at the top, right? So we would take this guy here. Obviously, this is a non-insulated fitting, right? We will go to the non-insulated part, which is going to be the one with that little dimple there. Put it right there. Give it a good squeeze. All right. So there you guys can see it made that little dimple. All right. This guy ain't coming out. All right. That's her home now. And she's staying put. And one I forgot to tell you guys about, right? Or two fittings I forgot to tell you about. So you got these little guys here. All right, these guys here is called spade fittings. Let's see if I can find that. So if you're looking at this guy here where the thermostat wires go, you would just get this guy, slide it right in there, and then just screw it down, and it should be nice and snug for you. Right. And then this guy here, right? You can see how it's has that little guy that pops up, right? A little quick connect. You got a male and a female. So the female will go, we'll just say, you don't have any more space. Oh, there we go. You don't have any more space down here to put any more fittings. So you would actually just put this guy here like so, right? And then boom. Now you have another spot where you can plug another wire in case you're, one short. You can do this guy here, boom, you're good. All right. So that's crimping for you guys. Now, I've always taught at a young tech age, this is how you do it, and I've seen why multiple times. And some of you guys that might have a little bit of electrical background, some of you guys might agree. I've had a lot of guys here that have come through here that had a little bit of electrical, and like, no, that's not how I was taught. Well, this is how I'm teaching you because this is the way the majority of the trade operates, right? So you got those two wires there and you want to mate them together, right? What a lot of guys always tend to do is that they get the wire, twist them like that. I don't have an issue with that. That's not where the issue lies. But then they put these two guys together, right? Just like so. And then they twist these two guys together. That's where my issue lies. Don't twist these guys. You will not get a better bond by doing that. You will actually get a weaker bond. So when we go to test and pull these wires here, a lot of times these guys, you see this little cap just whoop, take off like a rocket, right? So we're not going to do that, and hopefully you guys don't ever do that. But again, I'm teaching you guys my ways. When you guys are out in the trade, you guys will probably learn different stuff, All right, but this is just me. So what you actually do is just get these two guys like so, right? Get your cap, put this guy in here, and then you just start to twist. All right, doesn't want to turn anymore. You would just get this guy, you will pull. Now, really pulling here, they ain't coming out, right? So she ain't budging, right? So this is a good bomb. Now, again, when my journeyman, I got a little sweat going on. When my journeyman taught me how to do this stuff here, he would tell me, hey, Melendez, put the wire nut on there before you put any electrical tape on here, or before you close this panel. You give this thing a good tug, right? If it's later on in the day and it's about 120 degrees outside, and you feel weak, obviously you're going to lose arm strength, and you feel like you're not getting a good pull, ask your journeyman, ask your partner, hey man, you want to check my wires, you want to give me a little pull, see if the wire nuts are good, right? What you don't want to do is you don't want to think you did a good job putting this guy on there, and over a couple of days or minutes or seconds or hours, you know, this guy's sitting inside of a electrical panel and sometimes there's a little bit of vibration going on. What you don't want is this cap to actually back off, right? Here you guys can see how good she is, right? So you don't want this little guy to back off and then this piece of wire go up and touch a panel or a ground. What's going to happen? There's going to be a little bit of fireworks going on depending on the voltage. Those are going to be go backs, right? So you don't want to cause, you know, an unnecessary callback for you, right? If it can be prevented, might as well do it, okay? But that's pretty much simple. The simple stuff that I kind of wanted to cover with you guys. Oh, real quick, this guy I was going to show you, right? So these two guys are the same, right? This guy here is non-insulated, right? We're talking about the actual quick connect. And then here, this guy is insulated. So you can see how the quick connect sits inside, and then you have this plastic case on the outside. This is an insulated, non-insulated, right? But that's pretty much it. It's all I kind of wanted to cover with you guys. Hopefully I'll be making another video tomorrow. So I'll be posting this guy up tonight, which is the 14th of May. So I'll post this guy up tonight. Again, if you guys have any questions, you know, email me, call me, text, whatever you guys got to do. Get a hold of me, ask me the question. More than gladly answer it. And then tomorrow I'll make another little video and actually show you guys real quick. I'll actually be walking you guys through this little kit here, right? So this guy has fans, contactors, obviously a little disconnect here, transformer, this little light bulb down here. This little light bulb down here will act as our heater. We got relays, sequencers, you know, thermostat, even though it's missing the face, and this guy will operate as our compressor, condenser fan, and indoor fan. So I'll actually show you guys how to wire this guy up tomorrow. You guys can see here we got a little bit more stuff going on there. So I'll show you guys how to wire that tomorrow. So I'll be drawing on the board and explain stuff to you guys. So make sure you guys stay aware that that video will be up tomorrow. I'll probably film it now and then upload it tomorrow for you guys. All right. So again, you guys got any questions, hit me up, text, call me, email me, whatever you guys got to do. All right. Take it easy.